Hello students, welcome to your channel Parivartan Physics. See, we are in the series of videos where we are going through rapid revision course for KCET 2025 and we have revised 7 chapters up till AC from second PUC Physics. Right, in one video we are revising one full chapter. So in these videos we are learning concepts, shortcuts and formulas of that complete chapter in one video, right? So if we are continuing that series now up till AC we have completed. So in this video we are going to see completely about ray optics, right? So let us begin ray optics without any delay now. Okay, see here. This is about reflection. Here we have a mirror and this is the incident light ray. So incident light ray, it will hit the mirror and it will get reflected back in this direction, right? So the reflected light ray will pass in this direction. So this is the reflected light ray. This is the incident light ray and this is the reflected light ray. This is the normal. Angle between incident ray and normal is called angle of incidence. Normal and reflected light ray is angle of reflection. In reflection, we know very well angle of incidence will be equal to angle of reflection. Where in reflection, this is law of reflection. Correct? What is this angle called as? This angle is called angle of glancing. Angle between the incident ray and the surface of the mirror is called angle of glancing. Angle between incident ray and the normal is called angle of incidence. Angle between reflected ray and normal is called angle of reflection, right? Then angle between reflected light ray and the incident light ray is the original direction of incident light ray, correct? This is reflected light ray. So this is called deviation. This angle is called deviation, right? So this angle is called deviation. So the deviation produced by the plane mirror is given as d is equal to 180 degree minus 2i. I is angle of incidence, right? So remember the formula, deviation produced by plane mirror is 180 minus 2i, correct? Okay, that's all about the reflection through plane mirror as well as deviation. Next we'll see some important points related to the reflection through plane mirror. See, magnification of plane mirror is 1, right? Yakandre plane mirror will produce the same size of image and the image will be at the same distance as that of the object. So if plane mirror then the object ikade ಎಷ್ಟು ದೂರ ಇದೆ, image ಕೂಡ ಅಷ್ಟೇ ದೂರ ಇರ್ತದೆ. If the object is vertically upwards, image will also be vertically upwards. If the object is of height 10 meter, image will also be of height 10 meter only. Same size at the same distance, image will be formed. That's why its magnification will always be 1, right? Unmagnified under same size of the image irtade, virtual and erect image you will get from plane mirror. Next point is, if object moves with velocity u towards or away from the mirror, then image will also move with velocity u towards or away from the mirror. So mirror kadege ನೀವು ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಅನ್ನು 20 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ದಿಂದ ನೀವು ಮೂವ್ ಮಾಡ್ಲಿಕ್ಕೆ ಶುರು ಮಾಡ್ರಿ ಅಂತಂದ್ರೆ ಇಮೇಜ್ ಕೂಡ 20 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ದಿಂದ ಟುವರ್ಡ್ಸ್ ದ ಮಿರರ್ ಮೂವ್ ಆಗ್ತದೆ. If you move it away, image will also move away from the mirror, right? That is the meaning of that point. Next point is, if a mirror is moved towards or away from a static object with the speed v, then the image moves towards or away from the object with the speed 2v. See, when the mirror was static and the object was moving, with how much velocity the object was moving, with the same velocity the image was moving. Object ಎಷ್ಟು ಸ್ಪೀಡ್ಲಿ ಹೋಗ್ತದೆ, ಇಮೇಜ್ ಕೂಡ ಅಷ್ಟು ಸ್ಪೀಡ್ಲಿ ಹೋಗ್ತಿತ್ತು. ಅವಾಗ ಮಿರರ್ ಸ್ಟಾಟಿಕ್ ಇತ್ತು. ಇಲ್ಲೇ ಆಬ್ಜೆಕ್ಟ್ ಇಸ್ ಸ್ಟಾಟಿಕ್, ಮಿರರ್ ಇಸ್ ಬಿಂಗ್ ಮೂವಿಂಗ್, ರೈಟ್? ಮಿರರ್ ಮೂವ್ ಮಾಡತ್ತೀವಿ. ಸೊ ಮಿರರ್ ವಿ ದಿಂದ ಮೂವ್ ಆದ್ರೆ ಇಮೇಜ್ ನಮಗೆ 2v ದಿಂದ ಮೂವ್ ಆಗ್ತದೆ. That is the meaning of this point. Okay, we'll go for the next point. In the next point, if a plane mirror is rotated through an angle A, then reflected light ray will rotate through an angle 2A. For example, ಈಗ ಒಂದು ಲೈಟ್ ರೇ ನಮಗೆ ಈ ತರ ಹೊಂಟದ ಅಂತ ಇಟ್ಕೋರಿ. If you rotate the angle by an angle A, angle A ದಿಂದ ನೀವು ಏನಾದರೂ ಮಿರರ್ ರೋಟೇಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಈ ರಿಫ್ಲೆಕ್ಟೆಡ್ ಲೈಟ್ ರೇ ನಮಗೆ 2A ದಿಂದ ರೋಟೇಟ್ ಆಗ್ತದೆ. It will rotate through an angle 2A, reflected light ray, right? Okay, next, see. In reflection, velocity, wavelength and frequency will remain same. Velocity, wavelength ಮತ್ತು frequency of the reflected light ray as well as incident light ray will be same. ಅದು ಚೇಂಜ್ ಆಗಂಗಿಲ್ಲ. ಏನು ಚೇಂಜ್ ಆಗ್ತದಪ್ಪ ಅಂದ್ರೆ intensity ಚೇಂಜ್ ಆಗ್ತದ್ರಿ in reflection, right? Okay, we'll go for the next concept then. See, if two plane mirrors are inclined at an angle theta with each other, ಎರಡು plane mirrors ನಾವು ಈ ತರ ಇಟ್ಕೊಂಡಿದೀವಿ ಅಂತ ಇಟ್ಕೋರಿ. The angle between the two plane mirrors is theta and this is the bisector of that theta. Angle ಎರಡು equal of that divide ಮಾಡತೈತಿ. So the deviation produced by these two plane mirrors is given by d is equal to 360 degree minus 2 theta, where theta is the angle between the two mirrors. ಆ ಎರಡು mirrors ನಡುವಿನ angle ಇದು. So deviation in between the two mirrors is 360 degree minus 2 theta. Next, if the angle between the two mirrors is 90 degree, incident light ray and reflected light ray will be parallel to each other. For example, ಈಗ ನೋಡ್ರಿ, if you incident a light ray here, ಇಲ್ಲಿ ಒಂದು ಲೈಟ್ ray ನೀವು ಇನ್ಸಿಡೆಂಟ್ ಮಾಡಿದ್ರೆ ಇವತ್ತು ನೋಡು ಸಪೋಸ್ ಸಪೋಸ್ ನಮಗೆ 90 ಡಿಗ್ರಿ ಆಂಗಲ್ ಇತ್ತಪ್ಪ ಅಂತಂದ್ರೆ, ಸಿ ಇಫ್ ದ ಮಿರರ್ಸ್ ಆರ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ಈಚ್ ಅದರ್ ಲೈಕ್ ದಿಸ್, ಇಫ್ ದಿಸ್ ಇಸ್ ದ ಫಸ್ಟ್ ಮಿರರ್ ಅಂಡ್ ಇಫ್ ದಿಸ್ ಇಸ್ ದ ಸೆಕೆಂಡ್ ಮಿರರ್, the light ray which is incident at one mirror will get reflected by another mirror, and the reflected light ray will be like this. So the incident ray and the reflected light ray both will be parallel to each other. That is the meaning of the first point. Second point, if the angle between the two mirrors is 60 degree, incident light ray will be parallel to the second mirror, reflected light ray will be parallel to the first mirror, right? So it will be like this. Ignore it. For example, you namagu 60 degree angle ittapa antandre, if the angle between the two mirrors is 60 degree, if it is 60 degree, incident light ray will be parallel to the second mirror. E mirror ka parallel ಇದೆ. ಇದು ರಿಫ್ಲೆಕ್ಟ್ ಆಗಿ ಹೋಗಬೇಕಾದ್ರೆ when it reflects and goes back, at that time it will be parallel to the first mirror. ಇದು first mirror ನಮಗೆ reflected light ray parallel ಇರ್ತದೆ. This will be parallel to first mirror, this will be parallel to second mirror, right? Like that. Incident light ray will be parallel to the mirror on which it is not incident. ಇದು ನಮಗೆ incident ray. This is incident ray. ಇದು ನಮಗೆ first mirror ಅಂತ ಹಿಡ್ಕೋರಿ, ಇದು ನಮಗೆ second mirror ಅಂತ ಹಿಡ್ಕೋರಿ. Incident ray is parallel with second mirror, reflected light ray is parallel with first mirror, right? This will happen when the angle between the mirrors is 60 degree. Incident ray and reflected light ray will be parallel when the angle between the rays is when the angle between the mirrors is 90 degree, correct? Okay, let us go for the next question. Next concept, see, reflection at spherical mirrors. Spherical mirrors first sign conventions ಗೊತ್ತಿರಬೇಕು. We know very well incident light rays are always drawn from left to right direction. Incident light rays are always drawn from left to right direction. Heights measured above the principal axis are positive, heights measured below the principal axis are negative, distances measured in the direction of incident light ray are positive, distances measured in the opposite direction of light ray are negative, ಅಥವಾ distances measured in right side direction are positive, distances measured in left side direction are negative. All the distances are measured from the pole of the mirror ದಿಂದ measurement ಮಾಡ್ತೀವಿ. Relation between focal length of the mirror and radius of curvature is f is equal to r by 2 ಅಥವಾ r is equal to 2f. Relation between focal length and radius of curvature of spherical mirror. Next, mirror formula. 1 by f is equal to 1 by u plus 1 by v, where f is focal length, u is object distance, v is image distance. Lateral magnification, right? Lateral magnification of a mirror is given by magnification under casually. ಯಾವ್ತರದೇ ಇರಲಿ, ಲೆನ್ಸ್ ಇರಲಿ ಅಥವಾ ಮಿರರ್ ಇರಲಿ, it will be ratio of height of image to the height of object. So m is equal to height of image upon height of object, or minus v by u, or f divided by f minus u, or f minus v divided by f. So these many different forms we have for the magnification of a spherical mirror, right? Okay, so that is all about the magnification. Next note, image formation of a spherical mirror. Image formation by spherical mirrors. See, if here is the center of curvature, here is the center of curvature of the mirror, and here is the principal focus, here is the pole of the mirror. If the object is kept beyond C, ignore C kinta mundgade ನಾವು ಇಟ್ಕೊಂಡಿದ್ದೀವಿ. If the object is kept beyond C, the image will get formed in between C and F. Image ನಮಗೆ C and F ನಡು ಫಾರ್ಮ್ ಆಗ್ತದೆ. It will be real, inverted and diminished. Diminished ಅಂದ್ರೆ smaller in size compared to the object. Object compare ಮಾಡಿದ್ರೆ smaller ಇರ್ತದೆ. If the object is placed at C, then image will also get formed at C only. Image ಕೂಡ ನಮಗೆ at C ಒಳಗೆ ಫಾರ್ಮ್ ಆಗ್ತದೆ. It will be real, inverted and of same size. Same size of the object ಮತ್ತು image ಎರಡು same size ಇದ್ದು ಇರ್ತಾವೆ. Next ನೋಡ್ರಿ, if the object is kept in between C and F, C ಮತ್ತು F ನಡು ನಮಗೆ object ಇಟ್ಕೊಂಡಿದ್ರೆ, image will get formed beyond C. Image beyond C. ಮೊದಲಿನ ಕೇಸ್ ಏನೈತೆ ಅದರ ಅಪೋಸಿಟ್ ರೀ. ನೋಡ್ರಿ, ಮೊದಲ object beyond C ಇತ್ತು, image in between C and F ಇತ್ತು. ಈಗ object is in between C and F, so images beyond C. Images beyond C, right? It will also be real, inverted, but it will be enlarged. ನೋಡ್ರಿ, as we move object towards the mirror, object ನೀವು towards the mirror move ಮಾಡಿದಂಗ image is moving away from the mirror. Image is moving away from the mirror. What is happening for the size of the image? It is enlarging. Size of the image ನಮಗೆ enlarge ಆಗೋತ ಹೊಂಟತ್ರಿ. It is going on increasing, right? So next, finally, if you keep the object in between F and P, if you keep it here, if you keep the object here, then the image formed will be behind the mirror. It will be real, inverted and enlarged. Sorry, virtual, erect and enlarged, right? ಯಾವುದು ಇದು in case of concave mirror, right? Convex mirror, all these things are for the case of concave mirror. Convex mirror, wherever you keep the object, image will always be erect, virtual and diminished. Erect, virtual and diminished. For which mirror? For convex mirror, right? Okay, this is for concave mirror. Okay, let us go for the next concept, refraction. See, refraction ಒಳಗೆ ನಮಗೆ Snell's law ಗೊತ್ತಿರಬೇಕು. This formula you should be knowing perfectly. This is relative refractive index. Refractive index of second medium with respect to first medium, which is given by n2 by n1, or sin I by sin r, or v1 by v2, or lambda 1 by lambda 2, right? So refractive index ಹೆಂಗದ ಇಲ್ಲ, it is 2 by 1, second medium divided by first medium. Speed v1 by v2, wavelength lambda 1 by lambda 2. It indicates that the refractive index is inversely proportional to speed as well as inversely proportional to wavelength. Refractive index speed ಮತ್ತು wavelength ಎರಡಕ್ಕೂ inversely proportional ಅದೇ. Correct? Okay, next. What does refractive index indicates? Refractive index ಜಾಸ್ತಿ ಇದ್ರೆ ಅದು ಜಾಸ್ತಿ denser medium ಅದ ಅಂತ ಅಂದಂಗ. It is more denser medium. Right? ಜಾಸ್ತಿ dense ಇತ್ತಪ್ಪ ಅಂದ್ರೆ ಅದ್ರೊಳಗೆ ನಮಗೆ ಸ್ಪೀಡ್ ಏನಾಗ್ತದ್ರಿ reduce ಆಗ್ತದೆ. Okay, if refractive index is less, then that is called rarer medium or less denser medium, where the speed of the light will be more. Right? So, however, we already know n and v are inversely proportional. If n is more, v has to be less. If n is less, v has to be more. What are refractive index in indicate ಮಾಡ್ತದ? How dense is the medium? Medium ಎಷ್ಟು denser ಅದ? More the density of the medium, less will be the speed of the light. Less the density of the medium, more will be the speed of light. Right? Okay, next we'll note. We know very well in 7 colors, ಈ ವಿಬ್ಗ್ಯೂರ್ ಕಲರ್ಸ್ ಏನಿರ್ತಾವ್ರಿ ಅದ್ರೊಳಗೆ ರೆಡ್ ಕಲರ್ ದ ಲಾಂಗೆಸ್ಟ್ ವೇವ್ ಲೆಂತ್ ಇರ್ತದೆ, violet color the shortest wavelength ಇರ್ತದೆ. So if wavelength is longest, refractive index for that color will be less. If wavelength is shortest, refractive index for this will be more. Correct? Okay, next note. For vacuum, refractive index is 1, vacuum athwa air. For a diamond, refractive index is 2.5, which is highest. Correct? Okay, let us go for the next concept. Normal shift. See, normal shift andre enagtirtade illa nodri, we have taken a denser medium here. This is the denser medium whose refractive index is n. We have taken the object here. Illi namaga denser medium the end olaga illi namaga object adri. Here is the object, and we are observing it from the top of the medium. ಅಂತಂದ್ರೆ ನಾವು ಎಲ್ಲಿಂದ ಅಬ್ಸರ್ವ್ ಮಾಡತ್ತೀವಿ ಅದನ್ನ, we are observing it from rarer medium. Here is the observer. ಇಲ್ಲಿಂದ ನಾವು ಅದನ್ನ ನೋಡಾತೀವಿ. For example, you can say this one is bird, this one is fish. Correct? Okay, so object is in denser medium and observer is in rarer medium. ಈ ಕೇಸ್ ಒಳಗೆ ಏನಾಗ್ತದ್ರಿ, that object, we will feel that object is close to us. Right? ಆ ಆಬ್ಜೆಕ್ಟ್ ನಮಗೆ ದೂರ ಅದ ಅಂತ ಅನ್ಸಂಗಿಲ್ಲ. ಎಷ್ಟು ಆಕ್ಚುಲಿ ದೂರ ಅದ ಅದಕ್ಕಿಂತನೂ ಸಮೀಪದಪ್ಪ ಅಂತ ಅನಿಸ್ತದ್ರಿ. Right? Why? Because the image of this object is formed here. ಅದರದ ಇಮೇಜ್ ನಮಗೆ ಇಲ್ಲಿ ಫಾರ್ಮ್ ಆಗಿರ್ತದೆ. ಸೊ ನಮಗೆ ಕಾಣಿಸ್ತಿರೋದು ಆಬ್ಜೆಕ್ಟ್ ಅಲ್ಲ, ಆಬ್ಜೆಕ್ಟ್ ಇಮೇಜ್ ನಮಗೆ ಕಾಣಿಸ್ತಿರ್ತದ್ರಿ. That's why it appears close to us, and that is called normal shift. ಅದಕ್ಕೆ ನಾರ್ಮಲ್ ಶಿಫ್ಟ್ ಅಂತ ಕರೀತಾರೆ. ಸೊ ಆಬ್ಜೆಕ್ಟ್ ದಿಂದ ಇಮೇಜ್ ಎಷ್ಟು ಮೇಲ್ಗಡೆ ಫಾರ್ಮ್ ಆಗಿದೆ ಆ ಡಿಸ್ಟೆನ್ಸ್ ನಾರ್ಮಲ್ ಶಿಫ್ಟ್ ಅಂತ ಕರೀತಾರೆ. ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ನಾರ್ಮಲ್ ಶಿಫ್ಟ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ ನೋಡ್ರಿ, we have to measure all the distances from this point. ಈ ಪಾಯಿಂಟ್ ದಿಂದ ನಾವು ಮೆಜರ್ಮೆಂಟ್ ಮಾಡಬೇಕು ಡಿಸ್ಟೆನ್ಸ್ ಗಳನ್ನ. ಸೊ from that reason, I mean from this upper face to the object, ಇದಕ್ಕೆ ನೀವು ಆಬ್ಜೆಕ್ಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಅನ್ಬೋದು. From upper face to the image, ಇದಕ್ಕೆ ನೀವು ಇಮೇಜ್ ಡಿಸ್ಟೆನ್ಸ್ ಅನ್ಬೋದು. ಸೊ ಇಲ್ಲಿ ಏನು ಆಬ್ಜೆಕ್ಟ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಅದ ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಕ್ಚುಯಲ್ ಡೆಪ್ತ್. ಆಮೇಲೆ ಇಲ್ಲಿ ಏನು ಇಮೇಜ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಅದ ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಅಪ್ಪರ್ ಅಂಡ್ ಡೆಪ್ತ್. ಕರೆಕ್ಟ್? ಸೊ ಆಬ್ಜೆಕ್ಟ್ ಡೆಪ್ತ್ ನಮಗೆ ಎಷ್ಟದಪ್ಪ ಅಂದ್ರೆ ಆಕ್ಚುಯಲ್ ಡೆಪ್ತ್ ಅಥವಾ ಟ್ರೂ ಡೆಪ್ತ್ ಅಂತ ಏನ್ ಕರೀತಾರೆ, ದಟ್ ಇಸ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ ಆಬ್ಜೆಕ್ಟ್. ಆಬ್ಜೆಕ್ಟ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಅದು. ರೈಟ್? ಅದು ನಮಗೆ ಯು ಇದ್ರೆ ಇಮೇಜ್ ಡಿಸ್ಟೆನ್ಸ್ ನಮಗೆ ಅದಕ್ಕಿಂತ ಕಮ್ಮಿ ಇರ್ತದೆ. ಎಷ್ಟು ಕಮ್ಮಿ ಇರ್ತದಪ್ಪ ಅಂದ್ರೆ ಇಟ್ ವಿಲ್ ಬಿ n ಟೈಮ್ಸ್ ಲೆಸರ್. ಸೊ ಇಫ್ ದಟ್ ಈಸ್ ಯು, ದಿಸ್ ವಿಲ್ ಬಿ ಯು ಬೈ n. ರೈಟ್? ಯಾಕಂದ್ರೆ ಅದು ಎಷ್ಟು ಡೆಪ್ತ್ ಒಳಗದ ಅದಕ್ಕಿಂತ ಮ್ಯಾಗ್ ನಮಗೆ ಕಾಣಿಸ್ತಿರ್ತದ್ರಿ, ಮೇಲ್ಗಡೆ ಶಿಫ್ಟ್ ಆಗಿರ್ತದೆ. ಕರೆಕ್ಟ್? ಸೊ ಆಕ್ಚುಯಲ್ ಡೆಪ್ತ್ ಜಾಸ್ತಿ ಇರ್ತದೆ, ಅಪರೆಂಟ್ ಡೆಪ್ತ್ ಕಡಿಮೆ ಇರ್ತದ್ರಿ. ಆಕ್ಚುಯಲ್ ಡೆಪ್ತ್ ಮೈನಸ್ ಅಪರೆಂಟ್ ಡೆಪ್ತ್ ವಿಲ್ ಗಿವ್ ಯು ನಾರ್ಮಲ್ ಶಿಫ್ಟ್. ಅದು ನಿಮಗೆ ನಾರ್ಮಲ್ ಶಿಫ್ಟ್ ಅನ್ನು ಕೊಡ್ತದ್ರಿ 1. Otherwise, you can use the formula to calculate normal shift. Normal shift is given by u into the bracket 1 minus n2 by n1. Second medium air idre then you 1 anta tagobodu. Correct? See, here actual depth is greater than apparent depth. So refractive index will be equal to greater value divided by smaller value. Greater value is actual depth divided by apparent depth. Clear? This happens when object is in denser medium and observer is in rarer medium. Okay, the reverse case is here. When object is in rarer medium and observer is in denser medium. ಇಲ್ಲಿ ಒಳಗಡೆ ನಾವು ನೀರಿನೊಳಗೆ ಕುಂತು ನೋಡತ್ತೀವಿ ಅಂತಂದ್ರೆ ಈಗ ಫಿಶ್ ಏನದ, ಫಿಶ್ ಇದ್ದದ್ದು ಬರ್ಡ್ ನೋಡತ್ತ ಅಂದಂಗ್ರಿ. ರೈಟ್? ಸೊ ಅಬ್ಸರ್ವರ್ ಇಸ್ ಇನ್ ಡೆನ್ಸರ್ ಮೀಡಿಯಂ. ಈಗ ನೋಡ್ರಿ, ಆಬ್ಜೆಕ್ಟ್ ನಮ್ಗೆ ಇಲ್ಲದ. ಸೊ ಆಬ್ಜೆಕ್ಟ್ ಒರಿಜಿನಲ್ ಹೈಟ್ ಏನದ ಅಥವಾ ಒರಿಜಿನಲ್ ಡಿಸ್ಟೆನ್ಸ್ ಏನದ, ಆಬ್ಜೆಕ್ಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಏನದ, ಇದಕ್ಕೆ ನಾವು ಅಪರೆಂಟ್ ಆಕ್ಚುಯಲ್ ಹೈಟ್ ಅಂತ ಕರಿತೀವಿ. ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಕ್ಚುಯಲ್ ಹೈಟ್. ಇಮೇಜ್ ನಮಗೆ ಆಬ್ಜೆಕ್ಟ್ ಗಿಂತನೂ ದೂರ ಫಾರ್ಮ್ ಆಗಿರ್ತದೆ. ಇಮೇಜ್ ನಮಗೆ ಆಬ್ಜೆಕ್ಟ್ ಗಿಂತನೂ ದೂರ ಫಾರ್ಮ್ ಆಗಿರ್ತದೆ. ಕರೆಕ್ಟ್? ನಾವು ನೀರಿನೊಳಗೆ ಕುಂತು ಮೇಲ್ಗಡೆಯಿಂದ ನೋಡಿದ್ರೆ ಮೇಲ್ಗಡೆ ಸರ್ಫೇಸ್ ನಮಗೆ ಬಹಳ ದೂರ ಇರದೇ ಇದ್ರೂ ಕೂಡ ನಮಗೆ ಅದು ಬಹಳ ದೂರ ಅದಪ್ಪ ಅಂತ ಅನ್ನಿಸ್ತದ್ರಿ. ವೈ? ಬಿಕಾಸ್ ಇಟ್ಸ್ ಇಮೇಜ್ ಹ್ಯಾಸ್ ಗಾಟ್ ಫಾರ್ಮ್ಡ್ ವೆರಿ ಫಾರ್. ಸೊ ಆ ಇಮೇಜ್ ಏನ್ ಡಿಸ್ಟೆನ್ಸ್ ಅದರಿ ಆ ಡಿಸ್ಟೆನ್ಸ್ ನಾವು ಅಪರೆಂಟ್ ಹೈಟ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಇನ್ ಬೋತ್ ದ ಕೇಸಸ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ ಇಮೇಜ್ ಇಸ್ ಅಪರೆಂಟ್ ಅಂಡ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ ಆಬ್ಜೆಕ್ಟ್ ಇಸ್ ಆಕ್ಚುಯಲ್. ಹಿಯರ್ actual depth will be greater than apparent, actual will be greater than apparent. Here apparent will be greater than actual. ಇಲ್ಲಿ ಅಪರೆಂಟ್ ನಮಗೆ ರೆಡ್ಯೂಸ್ ಆಗಿರ್ತದ್ರಿ. ಎಷ್ಟು ರೆಡ್ಯೂಸ್ ಆಗಿರ್ತದ್ರಿ? n ಟೈಮ್ಸ್ ರೆಡ್ಯೂಸ್ ಆಗಿರ್ತದೆ. ಇಲ್ಲಿ ಅಪರೆಂಟ್ ನಮಗೆ ಇನ್ಕ್ರೀಸ್ ಆಗಿರ್ತದ್ರಿ. ಎಷ್ಟು ಇನ್ಕ್ರೀಸ್ ಆಗಿರ್ತದ್ರಿ? n ಟೈಮ್ಸ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿರ್ತದ್ರಿ. ಇಟ್ ವಿಲ್ ಇನ್ಕ್ರೀಸ್ ಬೈ n ಟೈಮ್ಸ್, n into u. Right? Okay, so here apparent height is greater than actual height, and in this case refractive index will be greater value divided by smaller value. Greater value is apparent height, smaller value is actual height. Clear? Okay, next note. Here lateral shift. lateral shift ಅಂತಂದ್ರೆ ಏನ, it is sideward displacement of the light ray. Sideward displacement. Okay, what is sideward displacement? See, actually the light ray was coming here. In this direction the light ray was coming. ಇಲ್ಲೊಂದು ಪ್ಯಾರಲಲ್ ಸೈಡೆಡ್ ಗ್ಲಾಸ್ ಸ್ಲಾಬ್ ನಾವು ಇಟ್ಕೊಂಡಿದ್ದೀವಿ, whose refractive index is n, thickness is t, ಅದರ thickness t ಅದ. So the light ray will come in this direction, it will get reflected and it will come here, again it will get reflected and it will go in this direction. ಇದಕ್ಕೆ ನಾವು emergent ray ಅಂತ ಕರಿತೀವಿ, ಇದಕ್ಕೆ ನಾವು incident ray ಅಂತ ಕರಿತೀವಿ, and this is called refracted ray. This is called refracted ray. So you can observe here the direction of incident light rays like this. ಇದು ನಮಗೆ incident light ray. Incident light ray ಬಿಟ್ಟು ನಮಗೆ emergent light ray ಈ ಕಡೆ ಶಿಫ್ಟ್ ಆಗಿತ್ತು. It has come in this direction. ನಮಗೆ ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಆಗಿಲ್ಲ ನೋಡ್ರಿ. These both are parallel to each other. ಇವೆರಡು ಒಂದಕ್ಕೊಂದು ಪ್ಯಾರಲಲ್ ಅದಾವ್ರಿ. ಕರೆಕ್ಟ್, ದೇ ಆರ್ ಪ್ಯಾರಲಲ್ ಟು ಈಚ್ ಅದರ್. ದೇರ್ ಇಸ್ ನೋ ಅ ಲಿಟಲ್ ಬಿಟ್ ಆಂಗಲ್ ಚೇಂಜ್ ಆಲ್ಸೋ. ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಕೂಡ ಡೈವರ್ಟ್ ಆಗಿಲ್ಲ. ದೇರ್ ಇಸ್ ನೋ ಡೆವಿಯೇಷನ್, ರೈಟ್? ಸೊ ಬೋತ್ ಆರ್ ಪ್ಯಾರಲಲ್. ಸೊ ದೇರ್ ಇಸ್ ನೋ ಚೇಂಜ್ ಇನ್ ದ ಡೈರೆಕ್ಷನ್. ಆಂಗಲ್ ಚೇಂಜ್ ಆದ್ರೆ ಚೇಂಜ್ ಇನ್ ದ ಡೈರೆಕ್ಷನ್ ಅನ್ಬೇಕು. ದೇರ್ ಇಸ್ ನೋ ಚೇಂಜ್ ಇನ್ ದ ಡೈರೆಕ್ಷನ್. ದೇ ಬೋತ್ ಆರ್ ಪ್ಯಾರಲಲ್. ಬಟ್ ವಾಟ್ ಹಸ್ ಹ್ಯಾಪನ್ಡ್, ಇಲ್ಲಿ ಬರಬೇಕಾಗಿದ್ದ ಲೈಟ್ ರೇ ನಮ್ಗೆ ಈ ಕಡೆ ಶಿಫ್ಟ್ ಆಗಿತ್ತು. ಇಟ್ ಹಸ್ ಕಮ್ ಓವರ್ ಹಿಯರ್. ಇಲ್ಲಿಂದ ಬರಬೇಕಾಗಿದ್ದ ಲೈಟ್ ರೇ ಇಲ್ಲಿಂದ ಹೊರಗಡೆ ಬಂದತ್ರಿ. ಸೊ ಅದು ಸೈಡ್ ವರ್ಡ್ ಎಷ್ಟು ಡಿಸ್ಪ್ಲೇಸ್ ಆಗಿದೆ, ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಲ್ಯಾಟರಲ್ ಶಿಫ್ಟ್. ಅದಕ್ಕೆ ಲ್ಯಾಟರಲ್ ಶಿಫ್ಟ್ ಅಂತ ಕರೀತಾರೆ. Lateral shift is calculated by using the formula T sin I minus R divided by cos R, where I is angle of incidence, R is angle of refraction. Here will be the angle of refraction, here is the angle of incidence, right? Next note, if angle of incidence is 90 degree, angle of incidence 90 degree ಅಂದ್ರೆ light ray ನಮಗೆ ಎಲ್ಲಿ ಬರ್ತದ್ರಿ? Where the light ray will come, the light ray will be here. ನಮ್ದು incident light ray ಇಲ್ಲದ ಅಂದಂಗ್ರಿ. If angle of incidence is 90 degree, so now I can say angle of incidence is 90 degree. Then this light ray will come out from here. Ee light ray naಮಗೆ ಇಲ್ಲಿಂದ emerge out ಆಗ್ತದೆ. It will emerge from here, right? So how much is the lateral shift? This was the original direction of the light ray. ಆ original direction light ray ಹಿಂಗದ್ರಿ. ಇಲ್ಲಿಂದ ನಮಗೆ ಎಷ್ಟು ಶಿಫ್ಟ್ ಆಗೈತ್ರಿ? So how much is the lateral shift in this case? It is equal to thickness of the glass slab. Thickness of the glass slab equal ಅದ. So lateral shift is equal to T. Mathematically calculate ಮಾಡ್ಕೊಂಡ್ರೆ ನಿಮಗೆ ಅಷ್ಟೇ ಬರ್ತದೆ. If I is equal to 0, it will be 0. I is equal to 0 ಅಂದ್ರೆ ಏನ? ನಾರ್ಮಲ್ ಇನ್ಸಿಡೆನ್ಸ್. ನಾರ್ಮಲ್ ಇನ್ಸಿಡೆನ್ಸ್ ಲೈಟ್ ರಿಫ್ರಾಕ್ಟ್ ಆಗೋದೇ ಇಲ್ರಿ. ಇಟ್ ವಿಲ್ ಗೋ ಇನ್ ದ ಸ್ಟ್ರೇಟ್ ಪಾತ್. ದಟ್ಸ್ ವೈ lateral shift will be 0, right? We'll go to the next concept then. See, total internal reflection. What is total internal reflection? Whenever a light is traveling from denser to rarer medium, if the angle of incidence is greater than critical angle, instead of going to the next medium, light will come back to the same medium. That is total internal reflection. See here what happens when a light ray is incident. When a light ray is incident on the interface. Interface ಅಂದ್ರೆ ಏನ? ಇಲ್ಲಿ ನಮಗೆ ಡೆನ್ಸರ್ ಮೀಡಿಯಂ ಅದ. This is the denser medium. Here is the rarer medium. Here is the rarer medium, right? So when a light is incident on the interface of the denser and rarer medium, and if the angle of incidence, ಇಲ್ಲಿ ನಮಗೆ angle ಅದ. If this angle of incidence, before that, if the angle of refraction is 90 degree, if the angle of refraction is 90 degree, then the angle of incidence is called critical angle. Angle of refraction ನಮಗೆ 90 degree ಇತ್ತಪ್ಪ ಅಂತಂದ್ರೆ, then its angle of incidence is called critical angle. ಅದರದ angle of incidence critical angle ಅಂತ ಕರಿತೀವಿ. ಅವಾಗ ಲೈಟ್ ರೇ ನಮಗೆ ಹೆಂಗ್ ಹೋಗ್ತಿರ್ತದಪ್ಪ ಅಂದ್ರೆ along the interface ಹೋಗ್ತಿರ್ತದ್ರಿ. ಅದೇನು ಬಾರ್ಡರ್ ಇರ್ತದಲ್ಲ ಎರಡು ಮೀಡಿಯಂ ದ, along that it will be going, right? Next, if I incident a light ray, ಇದು ನೋಡ್ರಿ, ಇದು ಸೆಕೆಂಡ್ ಲೈಟ್ ರೇ. This is incident at an angle greater than critical angle. Critical angle ಕಿಂತನೂ ಜಾಸ್ತಿ angle ಒಳಗೆ ನೀವು ಇನ್ಸಿಡೆಂಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ, light ray instead of going to the next medium, it will come back to the same medium. That is called total internal reflection. So total internal reflection ಆಗ್ಲಿಕ್ಕೆ ಎರಡು ಕಂಡೀಷನ್ಸ್ ಅದಾವ್ರಿ. One is angle of incidence must be greater than critical angle. Light must be traveling from denser medium to rarer medium. Light denser to rarer travel ಆಗ್ತಿರ್ಬೇಕು. These are the two conditions for total internal reflection. And if the angle of refraction is 90 degree, angle of incidence is considered as C. What? Critical angle, C ಅಂತಂದ್ರೆ. What is the relation between critical angle and refractive index? Sin C is equal to 1 divided by n. This is the relation between critical angle and refractive index. See, critical angle is inversely directly proportional to wavelength. Why? Refractive index is inversely proportional to wavelength, right? Ille critical angle ನಮಗೆ inversely proportional to refractive index ಅದರಿ. Critical angle is inversely proportional to what? Refractive index. That's why critical angle and wavelength are directly proportional. Wavelength ಯಾವ ತರದ್ದು ಹೆಚ್ಚಿರ್ತದ್ರಿ? ರೆಡ್. ಲೆಸ್ ಯಾವ್ದ್ರದ್ದು ಇರ್ತದ್ರಿ? ವೈಲೆಟ್. So critical angle will be more for red color and less for violet color. Okay, casually total internal reflection ಮೇಲೆ ಈ ತರದ್ದು ಒಂದು ಕೇಸ್ ಬರ್ತದ್ರಿ. They will tell you either a bulb is at the bottom of the swimming pool, or there is a swimmer, or there is a fish under the water at a certain height. If it looks upwards, ಮೇಲ್ಗಡೆ ಹೊರಗಡೆ ವರ್ಲ್ಡ್ ಏನಿರ್ತದ್ರಿ, the outside world will be visible in a cone. ಒಂದು ಸರ್ಕ್ಯುಲರ್ ಪ್ಯಾಚ್ ಒಳಗೆ ಒಂದು ಕೋನ್ದಾಗ ವಿಸಿಬಲ್ ಇರ್ತದ್ರಿ. So they will ask you three things here. Either they will ask you how much is the semi vertical angle, that is critical angle, how much is the radius, this they will ask. See ಇಲ್ಲಿ ಏನಾಗ್ತಿರ್ತದ್ರಿ, ಹಿಯರ್ ಇಸ್ ದ ಆಬ್ಜೆಕ್ಟ್, ಇಲ್ಲಿ ನಮಗೆ ಆಬ್ಜೆಕ್ಟ್ ಅದ ಬಲ್ಬ್ ಅಥವಾ ಫಿಶ್, ಇಲ್ಲಿಂದ ಬರುವಂತ ಲೈಟ್ ನಮಗೆ ಈ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಹೋಗಿ ಇಲ್ಲಿಗೆ ಬಂದ್ರೆ ನಮಗೆ ಈ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಹೋಗ್ತಿರ್ತದ್ರಿ. ಸೊ ಹೌ ಮಚ್ ಇಸ್ ದ ಆಂಗಲ್ ಆಫ್ ರಿಫ್ರಾಕ್ಷನ್ ಹಿಯರ್? Angle of refraction is 90 degree. If angle of refraction is 90 degree, how much is the angle of incidence called as? It is critical angle. If this is critical angle, then this angle will be critical. Idu angle ನಮಗೆ critical ಇರ್ತದ್ರಿ. Correct? This is radius. ಇದು ನಮಗೆ radius ಅದರಿ. This is radius and this is the depth ಅಥವಾ height ಅಂತ ಕೊಡಬಹುದು. Correct? So ಇಲ್ಲಿ ನಿಮಗೆ radius ಕೇಳಿದ್ರೆ radius calculate ಮಾಡ್ಲಿಕ್ಕೆ ಒಂದು ಶಾರ್ಟ್ಕಟ್ ಅದ, d divided by root of n square minus 1. Otherwise you can apply the geometry for this, trigonometric functions apply ಮಾಡಿ ನೀವು solve ಮಾಡಬಹುದು. Okay, we'll go for the next concept then. So next concept is refraction at spherical surface. Spherical surface ಒಳಗೆ refraction ಆಗಬೇಕಾದ್ರೆ there will be two mediums, one is rarer medium, another one is denser medium. Object will be in rarer, image will form in denser. Reverse ಇರ್ತದ್ರಿ, but ಇದೊಂದು ಕೇಸ್ ನಿಮಗೆ ಅದ. So the formula for refraction through spherical surfaces minus n1 by u plus n2 by v is equal to n2 minus n1 divided by r, where r is called radius of curvature. n1 is refractive index of first medium, n2 is refractive index of second medium, object distance, image distance, radius of curvature. Magnification, ಇದ್ರೊಳಗೆ magnification ಎರಡು ತರ ಬರ್ತಾರ, lateral or transverse magnification and longitudinal magnification. Lateral or transverse magnification is height of image upon height of object, or n1 by n2 into v by u. Longitudinal is n1 by n2 into v square by u square. This is longitudinal magnification. Lateral ಮತ್ತು longitudinal difference ಏನ್ರಿ? If this is the curved surface, ನಮಗೆ ಆಬ್ಜೆಕ್ಟ್ ಈ ತರ ಇತ್ತಂದ್ರೆ ಅದಕ್ಕೆ lateral magnification ಇರುತ್ತೆ. If the object is like this horizontally, then it will be having longitudinal magnification. Power is equal to n2 minus n1 divided by r, right? Refractive power of spherical surface. Okay, let us go for the next concept then. Okay, lens. Lens, we know at least one side of the lens has to be curved and it is a transparent medium, right? So lens formula, 1 by f is equal to minus 1 by u plus 1 by v. Lens formula. Magnification, height of image upon height of object, or image distance upon object distance, right? Or f minus v divided by f, or f divided by f plus u. This is called magnification. See, magnification in case of mirror, it was minus v by u, here it is v by u. Mirror formula was 1 by f is equal to 1 by u plus 1 by v, and here it is minus 1 by u plus 1 by v. Correct? That is the difference. Okay, you have to remember the formulas at any cost. Okay, next note, lens maker's formula. 1 by f is equal to n21 minus 1 divide n21 minus 1 into the bracket 1 by r1 plus 1 by r2. Right? Actually, formula is 1 by r1 minus 1 by r2. But for solving problem, you take it as 1 by r1 plus 1 by r2. You will get the right answer. It's nothing to worry. Okay. While substituting the focal length for convex lens, you take the focal length positive. For concave lens, you take the focal length negative. That's it. Other than that, there is no need of applying any kind of sign convention for that, right? So you may say that here it will be minus y or put plus. That is for the sake of adjustment. Antadre ನೀವು sign convention apply ಮಾಡೋದು ಬೇಡ ಅಂತ ಅದು ಹಾಕಿದ್ದದ್ರಿ. Next ನೋಡ್ರಿ, equibiconvex lens. If it is equibiconvex lens, ಇಲ್ಲಿ ನೋಡ್ರಿ ಇದ ಫಾರ್ಮುಲಾ ದ ಡಿಫರೆಂಟ್ ಸಿಚುವೇಶನ್ಸ್ ಒಳಗೆ ನಾವು ಸಾಲ್ವ್ ಮಾಡ್ಕೊಂಡು ಇಟ್ಕೊಂಡಿದ್ದೀವಿ. Equibiconvex lens means radius of curvature of this and radius of curvature of this both will be same. Andre r1 and r2 both are equal, right? So this will be 1 by r plus 1 by r, which will be 2 by r, right? So n minus 1, 2n minus 1 divided by r ಬರ್ತದ್ರಿ. 1 by f is equal to 2n minus 1 divided by r. ಅದನ್ನ f is equal to ಬರ್ಕೊಂಡ್ರೆ you will get this much. F is equal to r divided by 2n minus 1. Similarly, equibiconcave lens. So ಇತರದು ಕೂಡ radius of curvatures same ಇರ್ತಾವ. r1 and r2 will be equal. Here also r1 and r2 was equal. So here the focal length is minus r divided by 2 into the bracket n minus 1. See, if it is a plane surface, its radius of curvature has to be taken infinite. ಯಾವುದೇ plane surface ಇರಲಿ ಅದರ radius of curvature ನಮಗೆ infinite ಇರ್ತದೆ. So in this case, r1 is equal to r. ಅಂದ್ರೆ ಇದರದ curved surface radius of curvature r, plane surface is infinite. Focal length will be equal to r divided by n minus 1 in this case, and here focal length will be minus r divided by n minus 1. Concave lens ಗೆ focal length negative ಇರ್ತದೆ, convex lens ಗೆ focal length positive ಇರ್ತದೆ, right? Okay, let us go for the next concept then. See, lens with different medium on its sides. ಈಗಲೇ ಒಂದು ಲೆನ್ಸ್ ಅದ, ನಮಗೆ ಈ ಲೆನ್ಸ್ ಅದ ಆ ಕಡೆ ಒಂದು ಮೀಡಿಯಂ ಬೇರೆ ಅದ, ಈ ಕಡೆ ಒಂದು ಮೀಡಿಯಂ ಬೇರೆ ಅದ, right? So the refractive index of the first medium is n1, refractive index of the second medium is n3, and there is the glass lens in between, and that glass lens is having a refractive index n2. Radius of curvature of this side is r1 and radius of curvature of this side is r2, right? ಎರಡು ತರದ್ದು radius of curvature ಬೇರೆ ಬೇರೆ ಅದ. So in this case, you can apply this formula: n3 divided by v minus n1 divided by u is equal to n2 minus n1 divided by r1 plus n3 minus n2 divided by r2. So this formula can be applied when there are different mediums. If there are no different mediums, you can apply the lens maker's formula. Okay, ಈಗ ಇಲ್ಲಿ ನೋಡ್ರಿ, ಈಗ ನಮಗೆ ಸಪೋಸ್ ಅ ಲೆನ್ಸ್ ಇಸ್ immersed in a liquid. ಈಗ ನಮಗೆ ಇದೊಂದು ಲಿಕ್ವಿಡ್ ಅದ. If this is a liquid and in this liquid if I am immersing a lens, if I am taking a lens here in this, right, ಇದ್ರೊಳಗೆ ನಾವು ಒಂದು ಲೆನ್ಸ್ ಏನಾದರೂ ಇಟ್ಕೊಂಡಿದ್ರೆ refractive index of the lens ನಮಗೆ NG ಅಂತ ಇರಲಿ, refractive index of liquid ನಮಗೆ NL ಅಂತ ಇರಲಿ. If refractive index of glass is greater than liquid, focal length of the lens increases, power decreases. However, power and focal length are inversely proportional. So if focal length increases, power decreases. ಯಾಕಂದ್ರೆ power ಅಂದ್ರೆ reciprocal of focal length. No change in the nature of the lens. ಅಂದ್ರೆ convex lens ತರ behave ಮಾಡ್ತದೆ when refractive index of glass is greater than liquid. Refractive index of glass ಮತ್ತು refractive index of liquid ಎರಡೂ ಸೇಮ್ ಇದ್ದಪ್ಪ ಅಂತಂದ್ರೆ this lens will act like a plain glass whose focal length will become infinite and lens will become invisible in that liquid, right, when both the both the refractive indices are same. Next, when refractive index of glass is less than the refractive index of liquid ಕಿಂತನೂ glass ನಮಗೆ rarer ಆಯ್ತಪ್ಪ ಅಂತಂದ್ರೆ their nature of the lens will change. Convex ಇದ್ದದ್ದು concave ತರ behave ಮಾಡ್ತದ್ರಿ, concave ಇದ್ದದ್ದು convex ತರ behave ಮಾಡ್ತದ್ರಿ, right. In this case, if they ask you the focal length of the lens in the liquid or focal length of the lens in the air, ಇಲ್ಲಿ ನೋಡ್ರಿ ಇಲ್ಲಿ FL ಅಂತಂದ್ರೆ FL means it is focal length of the lens, focal length of lens in liquid, focal length of lens in liquid. This is focal length of lens in liquid. FA means it is focal length of lens in air. It is focal length of lens in air. FL ಅಂದ್ರೆ focal length of liquid ಅಲ್ಲ, it is focal length of lens in liquid. FA ಅಂದ್ರೆ focal length of air ಅಲ್ಲ, focal length of lens in air, right. So ಇವ್ ಎರಡರಾಗ ಒಂದು ಫೈಂಡ್ ಮಾಡ್ರಿ ಅಂತ ಕೇಳ್ತಾರೆ. Here we have refractive index of glass with respect to air -1 divided by refractive index of glass with respect to liquid -1. Correct. So using this formula you can calculate the focal length in case of immersion of the lens in the liquid. Okay, let us go for the next concept, power of lens. We know very well power of lens is the ability of the lens to bend the light rays, which is reciprocal of focal length. SI unit of power is diopter or per meter ಅಂತ ಹೇಳಿ ತಗೋಬಹುದು. For convex lens power is positive, for concave lens power is negative. Equivalent combination of lenses. If two lenses are brought in contact with each other, if two lenses are brought in contact with each other, ಈ ತರ ಎರಡು ಲೆನ್ಸ್ಗಳು ಒಂದಕ್ಕೊಂದು ಟಚ್ ಒಳಗೆ ಇದ್ದಪ್ಪ ಅಂದ್ರೆ and the focal lengths are different, the effective focal length of these two lenses together is 1 by f is equal to 1 by f1 plus 1 by f2. Effective power 1 by f ಅಂದ್ರೆ power, 1 by f1 ಅಂದ್ರೆ p1, 1 by f2 ಅಂದ್ರೆ p2, p is equal to p1 plus p2. Magnification m1 into m2. See, effective focal length will be sum of reciprocals of the focal length, effective power will be sum of the powers, but magnification will be product of the magnifications, it will not be the sum in particular. If these two lenses are separated now, ಅಂದ್ರೆ ಇವೆರಡು ಲೆನ್ಸ್ಗಳಿಗೆ ನಾವು ಸಪರೇಟ್ ಮಾಡಿದೀವಿ ಅಂತ ಇಟ್ಕೊಡಿ, ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದ ಲೆನ್ಸ್ ನಮಗೆ x ಅದ ಅಂತ ಇಟ್ಕೊಡಿ, ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದ ಲೆನ್ಸ್ ಇಸ್ x, ಇದು f1 ಅದ, ಇದು f2 ಅದ. Then 1 by f is equal to 1 by f1 plus 1 by f2 minus x divided by f1 into f2. Power will be p1 plus p2 minus x into p1 into p2, right, and m will be m1 into m2. So these are the formulas when the lenses are separated. If the lenses are in contact, you use these formulas only. If they are separated, you use these formulas, right. Next note, if a medium of refractive index n is filled in between the lens, ಇಲ್ಲಿ ಏನಾದರೂ ಒಂದು ಮೀಡಿಯಂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ in between the lens, ಅವಾಗ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡ್ರಿ. ಇಲ್ಲೇ ಸೇಮ್ ಫಾರ್ಮುಲಾ ಬಟ್ x divided by n ತಗೋಬೇಕು, because the distance get reduced. x ಜಾಗದಾಗ x divided by n ತಗೊಳ್ರಿ, right. Okay, that's all about the power of the lens. Next, cutting of the lens. If you cut the lens along the axis vertically, then the focal length of the lens will get doubled. F with the 2f ಆಗ್ತದೆ. If you combine them in any way, equivalent focal length will be f only. ಯಾವುದೇ ತರ ನೀವು combine ಮಾಡ್ಕೊಂಡ್ರು ಕೂಡ equivalent f ಆಗ್ತದೆ. If you cut it horizontally, the focal length will remain same, and when you combine it in this way, same order f by 2, in the opposite order, focal length will be infinite. Silvering of lens. See, whenever you silver a lens, it may be plane or it may be biconvex or single convex lens. If you silver polish, then it will act like a mirror, and if it is convex, it will act like a concave mirror. If it is concave lens, it will act like a convex mirror. So the nature will get reversed. See, ಇಲ್ಲಿ ನಾವು plane surface ಎರಡು ತರದ್ದು plane surface silver polish ಮಾಡ್ಕೊಂಡಿದೀವಿ. ಕಾನ್ವೆಕ್ಸ್ ಅದು ಕಾನ್ಕೇವ್ ಮಿರರ್ ತರ ಬಿಹೇವ್ ಮಾಡ್ತದ್ರಿ, ಕಾನ್ಕೇವ್ ಅದು ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್ ತರ ಬಿಹೇವ್ ಮಾಡ್ತದೆ. ಫೋಕಲ್ ಲೆನ್ಸ್ ವಿಲ್ ಬಿ ದಿಸ್ ಮಚ್, ಇಷ್ಟು ಫೋಕಲ್ ಲೆಂತ್ ಇರ್ತದೆ. Here also we are having the same plano convex as well as plano concave lenses. ಅಲ್ಲಿ ನಾವು ಪ್ಲೇನ್ ಸರ್ಫೇಸ್ ಸಿಲ್ವರ್ ಪಾಲಿಶ್ ಮಾಡ್ಕೊಂಡಿದ್ವಿ, ಇಲ್ಲೇ ಕರ್ಡ್ ಸರ್ಫೇಸ್ ಸಿಲ್ವರ್ ಪಾಲಿಶ್ ಮಾಡ್ಕೊಂಡಿದ್ವಿ. ಸೊ ಹಿಯರ್ ಆಲ್ಸೋ ದ ನೇಚರ್ ವಿಲ್ ಚೇಂಜ್. ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್ ಅದ ಕಾನ್ಕೇವ್ ಮಿರರ್ ತರ ಬಿಹೇವ್ ಮಾಡ್ತದೆ, ಕಾನ್ಕೇವ್ ಲೆನ್ಸ್ ಅದ ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್ ತರ ಬಿಹೇವ್ ಮಾಡ್ತದೆ. ಸೊ ಫೋಕಲ್ ಲೆನ್ಸ್ ವಿಲ್ ಬಿ ಲೈಕ್ ದಿಸ್, ರೈಟ್. ಇಷ್ಟು ನಮಗೆ ಫೋಕಲ್ ಲೆಂತ್ ಇರ್ತದೆ. ಬೈ ಕಾನ್ವೆಕ್ಸ್ ಬೈ ಕಾನ್ಕೇವ್, if any one side of the curved surface is silver polished, again the nature will change. Convex lens ಅದು ಕಾನ್ಕೇವ್ ಮಿರರ್ ತರ ಬಿಹೇವ್ ಮಾಡ್ತದ್ರಿ, ಕಾನ್ಕೇವ್ ಲೆನ್ಸ್ ಅದು ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್ ತರ ಬಿಹೇವ್ ಮಾಡ್ತದೆ. ಫೋಕಲ್ ಲೆಂತ್ ವಿಲ್ ಬಿ ದಿಸ್ ಮಚ್, ರೈಟ್? ಇವು ಫೋಕಲ್ ಲೆಂತ್ ನಾವು ಲೆನ್ಸ್ ಮೇಕರ್ಸ್ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು. ಓಕೆ, ವಿಲ್ ಗೋ ಫಾರ್ ದ ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್, ದಟ್ ಇಸ್ ರಿಫ್ರಾಕ್ಷನ್ ಥ್ರೂ ಪ್ರಿಸಮ್. ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್, ಯು ಶುಡ್ ಬಿ ನೋಯಿಂಗ್ ದಿಸ್. ಸಿ, ಹಿಯರ್ ವಿ ಹ್ಯಾವ್ ಟೇಕನ್ ಅ ಪ್ರಿಸಮ್ and here we have the incident light. ಈಗ ನೋಡ್ರಿ, ಇದನ್ನ PQRS ಅಂತ ಬರ್ಕೊಂಡ್ರೆ, PQRS, PQ is incident light ray, QR is refracted light ray, RS is emergent light ray, right? So for the first phase, 2 refractions will be taking place here. ಇಲ್ಲಿ total 2 refractions ಆಗ್ತಿರ್ತಾವೆ. ಒಂದು for the phase AB, another one for the phase AC. 2 refractions are taking place. For the first phase, light is traveling from rarer to denser medium. For the second phase, light is traveling from denser to rarer medium. So angle of incidence for the first phase is here I1, angle of refraction is here R1. Second phase ಇದನ್ನ angle of incidence ತಗೊಳ್ರಿ, ಇದನ್ನ angle of refraction ಅಂತ ತಗೊಳ್ರಿ, because in minimum deviation position light ray will be symmetric. ಅಂದ್ರೆ ಇದು PQRS ಪಾತ್ ಒಳಗೆ ಹೋದ್ರೆ ನೀವು ಈ ಕಡೆಯಿಂದ ಬಿಟ್ರೆ it will come in SRQP, ಸೇಮ್ ಪಾತ್ ಒಳಗೆ ವಾಪಸ್ ಬರ್ತದ್ರಿ if it is in minimum deviation condition. That's why you can take this one as also angle of incidence or angle of emergence, right? Remember I1 R1, R2 I2. So you can apply Snell's law separately for this phase also and for this phase also. ಎರಡಕ್ಕೂ separately Snell's law apply ಮಾಡಬಹುದು. Okay, angle of prism is here. ಎರಡು refracting surfaces ನಡುವೆ ಏನು angle ಇರ್ತದೆ, this is called angle of prism. Equilateral prism ಅಂದ್ರಪ್ಪ ಅಂತಂದ್ರೆ, for equilateral prism angle of prism will be equal to 60 degree. Angle of prism, right? Okay, next, by Snell's law, for the first phase you apply refractive index, it will be sin I1 divided by sin R1. For second phase it will be sin I2 divided by sin R2, right? Deviation produced by the prism I1 plus I2 minus A. This is not minimum deviation, normal deviation, right? It is non-minimum deviation. So deviation is given by I1 plus I2 minus A. Angle of prism is R1 plus R2, R1 plus R2. At minimum deviation, nodri, ella angle ke deviation minimum irangilla. There will be one angle of incidence at which the deviation will be minimum. Practical ಒಳಗೆ ನೀವು ಗ್ರಾಫ್ ಹಾಕೊಂಡಿರ್ತೀರಿ, right? Prism ಮೇಲಿಂದ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮೇಲೆ ಆ ಗ್ರಾಫ್ ನಿಮಗೆ ಈ ತರ ಬಂದಿರ್ತದೆ. It will come like this. So first deviation will decrease, it will reach minimum and then it will increase. So minimum deviation ಇರ್ತದಲ್ಲ, ಆ ಕಂಡೀಷನ್ ಒಳಗೆ angle of incidence I1 and I2 both will be equal I. Refractions R1 and R2 both will be equal to R. So deviation will become 2I minus A. Deviation ನಮಗೆ 2I minus A ಆಗ್ತದೆ. Angle of prism will be 2R, ಅಥವಾ ನೀವು refraction angle is equal to A by 2 ಅಂತ ಬರೀಬಹುದು. Refraction angle. Refractive index of the prism sin A plus D by 2, sin A by 2. Right? ಇದನ್ನ ನೀವು ಥಿಯರಿ ಒಳಗೆ ಡೆರೈವ್ ಮಾಡ್ಕೊಂಡಿರ್ತೀರಿ. So that's all about the prism. In next ಇದ್ರಾಗ ಒಂದು ಎರಡು ಸ್ಪೆಷಲ್ ಕೇಸಸ್ ಬರ್ತಾವೆ. Just remember, if a light ray is incident normally on one face of the prism, it will come out grazing on another face of the prism. So ಇದಕ್ಕೆ normal incidence, grazing emergence ಅಂತ ಕರೀತಾರೆ. Okay, if this is grazing out, then how much will be the angle of refraction here? Angle of refraction will be 90 degree. If this is 90 degree, how much this angle of incidence is called as critical angle. ಅದನ್ನ critical angle ಅಂತ ಕರೀತಾರೆ. And if it is a equilateral prism, this will be 60 degree. ಇದು ನಮಗೆ 60 degree ಇರ್ತದೆ. So for the first, ನೋಡ್ರಿ, ನಾರ್ಮಲ್ ಇನ್ಸಿಡೆನ್ಸ್ ಇತ್ತಪ್ಪ ಅಂದ್ರೆ ಅದು ಎಲ್ಲೇ ಇರಲಿ, ಪ್ರಿಸಮ್ಗೆ ಇರಲಿ, ಪ್ಲೇನ್ ಗ್ಲಾಸ್ಗೆ ಇರಲಿ, ಯಾವುದಕ್ಕೆ ಇರಲಿ, ನಾರ್ಮಲ್ ಇನ್ಸಿಡೆನ್ಸ್ ಇತ್ತಪ್ಪ ಅಂತಂದ್ರೆ ಅಲ್ಲೇ ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್, ಆಂಗಲ್ ಆಫ್ ರಿಫ್ರಾಕ್ಷನ್ ಎರಡು ನಮಗೆ 0 ಇರ್ತವೆ. Angle of incidence and refraction, if it is normal incidence, I1 and R1 will be equal to 0. I2 will be 90 degree, R2 will be critical angle, right? Sorry, I2 ಅಲ್ಲ, ಇದು R2 ನಮಗೆ 90 degree ಇರಬೇಕು. R2 will be 90 degree, right? Okay, R2 will be 90 degree. For example, for the second phase we are speaking. So R2 will be 90 degree. Angle of incidence will be equal to critical angle. ಇದು ನಮಗೆ critical angle ಇರ್ತದೆ, right? Okay, deviation produced here will be equal to 90 degree minus C. 90 degree minus C. This much will be the deviation produced. Okay, ಇಲ್ಲಿ ನೋಡ್ರಿ, grazing incidence, grazing emergence. So both are grazing. That's why I1 and I2 will be 90 degree. R1 and R2 will be equal to C. R1 and R2. Sorry, now will correct adari. There is no need of taking this. For prism, we know very well. Outside angle is angle of incidence. Inside is angle of refraction. So the reverse ತಗೊಂತೀವಿ. We will get the answers like this. Angle of prism ಎಷ್ಟು ಬರ್ತದೆ, deviation ನಮಗೆ ಎಷ್ಟು ಬರ್ತದೆ. Grazing incidence, grazing emergence. Here I1 is 90 degree, I2 is 90 degree, right? I1 and I2. Then how much will be the R1 and R2? R1 and R2 will be equal to C, right? So A is equal to 2C, deviation is 180 minus 2C. Normal incidence, grazing emergence, 90 minus C. Grazing incidence, grazing emergence, 180 minus 2C. Correct? That is the deviation produced in these both cases. Finally, we'll go for the last concept, that is optical instruments. ಇದ್ರೊಳಗೆ ನಾ ಎರಡೇ optical instruments ತಗೊಂಡಿದ್ದೀನಿ. ನೀವು astronomical telescopes ಬಗ್ಗೆ ನೀವು ನೋಡ್ಕೊಬೇಕು. Simple microscope, it has only one convex lens, simple convex lens ಇರ್ತದ್ರಿ. So magnification formulas first ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು. ಇಮೇಜ್ ಫಾರ್ಮೇಷನ್ ಬಗ್ಗೆ ತಿಳ್ಕೊಡ್ರಿ. ಮೇನ್ಲಿ ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್ ಫಾರ್ಮುಲಾ ಗೊತ್ತಿರಬೇಕು. ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್ ಫಾರ್ಮುಲಾ ಎರಡು ಕೇಸ್ ಒಳಗೆ ಬರ್ತಾವ್ರಿ. One is image formed at infinity, another one image formed at least distance of distinct vision capital D. Andre for human eye, at how much close we can see correctly. Clear eye ಕಾಣಿಸಬೇಕಾದ್ರೆ ನಾವು ಎಷ್ಟು ಸಮೀಪ ಒಳಗೆ ಹಿಡ್ಕೋಬೇಕು 25 centimeter. At 25 centimeter you can see everything distinctly. Clear ಆಗಿ ನೋಡಬಹುದು. ಆ least distance of distinct vision ಅಂತ ಕರೀತಾರೆ, that is represented by capital D. Capital D is 25 centimeter. The value 25 centimeter for human eye. Remember. So when the image is formed at infinity, magnification of simple microscope will be D by F. When the image is formed at D, magnification of simple microscope will be 1 plus D by F. Right? Idu D by F, idu 1 plus D by F. Next, compound microscope ಒಳಗೆ ನೋಡ್ರಿ. Here will be having two lenses, ಎರಡು ಲೆನ್ಸ್ ಇರ್ತಾವಿಲ್ಲ. ಇಲ್ಲಿ ಒಂದೇ ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್ ಇರ್ತದ್ರಿ ಸಿಂಪಲ್ ಮೈಕ್ರೋಸ್ಕೋಪ್ ಒಳಗೆ. ಕಾಂಪೌಂಡ್ ಮೈಕ್ರೋಸ್ಕೋಪ್ ಒಳಗೆ ಎರಡು ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್ ಇರ್ತಾವ್ರಿ. ಐ ಪೀಸ್ and objective. Sorry, you reverse agidave. So eyepiece and objective. See, this is objective actually. This is objective and this is eyepiece. The lens which is close to eye is called eyepiece, and the lens which is close to object, it is called objective. So ಈಗ ನೋಡ್ರಿ, ಈ objective lens ಮುಂದ್ಗಡೆ ನೀವು object ಅನ್ನು ಇಟ್ಕೊಂಡಾಗ ಇದರದ inverted and real image ಇಲ್ಲಿ ಫಾರ್ಮ್ ಆಗ್ತದೆ. Its real and inverted image will get formed. It will form at the principal focus of the second lens. Second lens is the principal focus ಒಳಗೆ ಫಾರ್ಮ್ ಆಗ್ತದೆ. That is called intermediate image. ಇದು ಫೈನಲ್ ಇಮೇಜ್ ಅಲ್ಲ, ಇದು intermediate image. This is image formed by the first lens. Image formed by the first lens is real, inverted and magnified. ಅಂದ್ರೆ ಆಬ್ಜೆಕ್ಟ್ ಗಿಂತನೂ ಸ್ವಲ್ಪ ದೊಡ್ಡದಿರ್ತದೆ. But still we want to increase its lens, its height. That's why we are using the second lens. So ಈಗ ಸೆಕೆಂಡ್ ಲೆನ್ಸ್ ಒಳಗೆ ಏನಾಗ್ತದ್ರಿ, ಇದು ಆಬ್ಜೆಕ್ಟ್ ತರ ಬಿಹೇವ್ ಮಾಡ್ತದ್ರಿ. This will not act like object for second lens. For second lens, this image formed by the first lens will act like the object, and the image of this object will get formed here. ಇಲ್ಲಿ ನಮಗೆ ಅದರ final image form ಆಗ್ತದ್ರಿ. So this is the image which is visible in the eyepiece, right? So ಈ ಎರಡನೇ ಲೆನ್ಸ್ ಒಳಗೆ ನಮಗೆ ಇದು image ಕಾಣಿಸ್ತದ್ರಿ. This image is visible in this case. So the final image is virtual, inverted and magnified. Virtual, inverted and magnified, right? Okay, in this case at infinity the magnification will be VO divided by UO. Note VO ಅಂತಂದ್ರೆ VO means it is image distance of objective. UO means it is object distance of the objective lens. Image distance of the objective lens, object distance of the objective lens. Focal length of the objective, focal length of the eyepiece. Correct? Okay. So if the image is formed at infinity, magnification of compound microscope is given by VO divided by UO, D divided by focal length of eyepiece. VO by UO, D by focal length of eyepiece. Length of the tube, length of the tube ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ನಮಗೊಂದು ಟ್ಯೂಬ್ ಇರ್ತದ್ರಿ, ರೈಟ್? ಹಿಯರ್ ವಿಲ್ ಬಿ ಅ ಟ್ಯೂಬ್. ಎರಡು ಲೆನ್ಸ್ ಜಾಯಿನ್ ಮಾಡುವಂತ ಒಂದು ಟ್ಯೂಬ್ ಇರ್ತದೆ. ಆ ಟ್ಯೂಬ್ ದ ಲೆಂತ್ ರೀ, ಇಟ್ ವಿಲ್ ಬಿ ಆಬ್ಜೆಕ್ಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ ಆಬ್ಜೆಕ್ಟಿವ್ ಪ್ಲಸ್ ಫೋಕಲ್ ಲೆಂತ್, ಸಾರಿ ಇಮೇಜ್ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ ಆಬ್ಜೆಕ್ಟಿವ್ ಪ್ಲಸ್ ಫೋಕಲ್ ಲೆಂತ್ ಆಫ್ ಐಪಿಎಸ್. ಇಲ್ಲದ ನೋಡ್ರಿ, VO plus FE, that is length of the tube. Okay, this is when image is formed at infinity. When image is formed at D, magnification will be VO divided by UO into the bracket 1 plus D by FE, focal length of eyepiece, and length will be VO plus DFE divided by D plus FE. So you have to remember the magnification formulas here. Mainly magnification formulas you ನೋಡ್ಕೊಬೇಕು. Okay, so that's all about ray optics, right? ಈ ray optics ಮೇಲೆ ನಾನು ಲಾಸ್ಟ್ ಇಯರ್ ಕೂಡ one short video upload ಮಾಡಿದ್ದೇನೆ. If you want, you can watch that also, right? So that's all about the rapid revision of ray optics. In the next video we'll see wave optics, and then we'll continue with modern physics. Dear students, if you like the content of this channel, please don't forget to subscribe the channel and share the video, share the channel with your friends, right? Your subscription is my motivation. So whatever you require or whatever you need for the examination, on that I will be doing the videos. So these videos will help you for your preparation, right? And please don't forget to share your opinion about this series of videos. And if you need anything else, please put the comment in the comment box. I will try to make the video on that, right? So we'll continue this series again. Previously on the 2 days gap aitri, so please don't mind, I was not getting the time. As much as possible without making the delay, I will complete the remaining chapters also. Soon we are going to complete, and we'll continue the series again, right? Thank you so much. Please don't forget to subscribe the channel and share the channel. Thank you. We'll meet again in the next video. Thank you.